Very good morning to one and all present here. So we are moving on to the day 3 session 2. The session will be handled by Dr. Velayudham Palaniappan sir, who is currently acting as the manager in Ford Motors Company, Chennai. So without much delay, let me invite Vinod sir for introducing the speaker.
Okay, good morning, one and all. Let me introduce our resource person. Fortunately, today we have with us Dr. Velayudham as our resource person for handling this session. He's the manager, industry for implementation Asia, Pacific and Africa Ford Company. It's BTech from mechanical engineering from Government College of Technology, Coimbatore. And also his MBA, Loyola Institute of Business Administration, Chennai. Then PG Diploma in Machine Learning from Indian Institute of Information and Technology, Bangalore. He has more than 20 years of experience in automotive field, 15 years in Ford Motor Company, and 5 years in previous Motors. He is experienced in automotive quality, product development, program management, purchasing, manufacturing, and industry for implementation. Worked in various capacities of global, regional, and country levels. He got some professional achievements like launched several new supply base and maintain quality and supply chain to support parts and assemblies for Ford production line. Spearheaded to form a brand new Ford quality and development team at a new site. Successfully pursuing industry for pilot projects in Asia Pacific region and target to scale. And also Ford IT 2019 AI and ML hackathon winner. His passions: reading and writing automotive data science blogs, exploring heavily on prediction and cost-saving idea in automotive processes, teaching and making aware of industry for solutions to fellow team in business. Okay, I invite Dr. Velayudham sir for handling this session. Thank you, sir.
Yeah, thank you, Professor, for your nice words. So it's my pleasure to be part of this webinar. I'll share my screen. One sec. Are you able to see my screen?
Yes, sir. Please go ahead, sir.
Okay. I'll just... Okay. So good morning, everyone. So thanks for welcoming me to this webinar. So, I mean, this is a quick overview about Industry 4.0 in automotive sector. In fact, this is a very big topic. The 1.5 hours is not sufficient for this because there is a lot to cover in this. But I ensured a condensed material is prepared over here, and then I'll try to cover most of the topics, right? So if you have any questions in between, you can stop me, or I believe we can have 10 minutes in the end for going through any Q&A sessions, right? Okay, moving on. Okay, so here's the quick outline of today's discussion. I'll touch upon what is Industry 4.0. This must be very familiar to most of you because you are going through a host of webinars about Industry 4.0. So I'll touch in very brief. And then a quick automotive journey, what was before and what is now, and why we need Industry 4.0, and what are all the Industry 4.0 technology drivers which is currently being used, and some briefing about those technology drivers with some examples I have. And also I will end it up with some of the challenges which we are currently facing in implementing these technologies and implementing this in real-time scenario. And also have some few advices to my college buddies and graduates. Okay, so what is Industry 4.0? So I mean, as you know, there are four industrial revolutions, right? The first revolution, it started with mechanizing the complete production plants, or be it some locomotives. Everything is with water and steam power. So that happened in the late 18th century. And moving on around early 20th century, the electrical energy, it revolutionized the complete production, everything. So exactly in this phase only, the Henry Ford, in fact, he revolutionized the vehicle car manufacturing with, I mean, implementing the conveyor belt line, right, for the mass production, right? So that is about the second revolution. Then on early 1970, it was all about electronics and IT. That completely automated the production line. So that further improved from the second revolution to the third. And currently what we are in now is the called fourth revolution. It is nothing but it's a combination of physical systems with the cyber physical system with the what to say, the Internet of Things. In industrial terms, we call it as IIoT, Industrial Internet of Things. Otherwise, it's all Internet of Things. So this is a quick summary about Industry 4.0, about each and every phase. I have a video to top it up. Maybe I will play it quickly, then we will go further. If you are unable to listen to the video, please let me know. Otherwise, I will get going. Okay, so that's the quick summary about I 4.0 phases. So moving on, we touched upon the cyber physical systems. So what is cyber physical systems? It's nothing but a digital overlay of the physical world. So what we see with our naked eye is the physical world, right? And if we overlay it with the digital world, and it is called the cyber physical system. So let's take an example of connected cars. I don't know how many of you are knowing about the connected cars. So it's nothing but connecting the IoT devices to the car and collecting the data in real time from the car important parts, right? And those data are being used for either by the owners, car owners, or by the manufacturers and all that. So that's something what the actual car running is the physical system, and the complete health of the car and the data from the car, which is taken at real time, which is monitored for several purposes. So that's something is the digital world. So it's a kind of a digital overlay on the physical world. So that's called the cyber physical system. So similarly, if you look at the digital factory, right? For example, if you are running a factory and with some n number of machines, right? So the complete the productivity, the production status and everything, if we can able to see it through a digital way, right? So manner. So that is called the cyber physical system. So anyway, we will touch more about it in the coming slides. Okay. To touch upon how the automotive journey is. So this seminar is about automotive. So I wanted to have some couple of slides included for automotive journey and how it is in this industry 4.0 implementations and implications, right? So as you know, I touched upon in the second revolution of industry 4.0. I mean, in the second revolution, it was around early 19th century. So Henry Ford, he introduced the conveyor line. What you could see it on the top picture is there is a conveyor line in which car is being produced. So before this period, there was no conveyor line, and every car is produced and all the parts has to come to a single location and the car has to be produced. But this, once the conveyor line was introduced, the parts will come here and few operations will happening, and then the next operation will happen on the next line of the conveyor, right? Next step of the conveyor, portion of the conveyor. So this is what the conveyor production. So the mass production started with this idea, and it was hugely successful during that period. But even today, after 100 years, 100 plus years is gone, but still we are using this conveyor line for the mass production. But only difference is, as you could see, this car models per line, it was one then, but now it is around 6 car models per line. This is something in average, but some manufacturers are producing more than this number as well. So there is what has changed between us, there is a flexibility is being introduced in the tools and fixtures, which has been there in the conveyor line. So that helped or aided for the more car models being produced on the production line. Okay, that is what has happened. But is that sufficient? That is a question now. Okay, so if you look at the automotive world, the customer expectations, right, has become very, very high now. The customer started expecting everything more customized. Okay, for example, if you are ordering anything in Amazon or anything in Flipkart, you wanted a T-shirt, gets it printed, right? You want your T-shirt to be customized. You want your coffee mug to be customized with your name, right? So everything you want it to be customized. So similarly, from the car also, the customer wanted in a different color, and they wanted with the different interior particulars. They wanted with the different tires, different front end, different rear end, and all that stuff, right? So, and they also wanted it in a very quick time, very faster response they wanted. If any issue happened to the car, if they are leaving it to the dealer end, right, they wanted it to be repaired very fast. They're expecting a faster response. And they, of course, they expect it with the less cost and very high quality. So, so it has become a highly cost competitive market, and business is really becoming very difficult now. So at this situation, if we have to survive in this automotive industry, what is important is we ultimately need to meet customer demands, customer expectations, but how to meet it, and what is the technology, and what is there to meet it. So that is where the industry, the 4.0 technologies are really helping out, and hence the manufacturers are looking at this way. How the 4.0 technologies can be implemented in their production line, how to leverage the benefits of these technologies for them in terms of reducing cost and improvement, customer satisfaction improvement, and implementing addressing the quality issues and all that, right? So, okay, so that's the demand which we know that, okay, customer wanted something, so we need to meet. So why should we look for only industry 4.0 technologies? Why not other technologies, right? So in fact, conventionally, there were a lot of technologies just before industry 4.0. If you know that there are a lot of lean methodologies were there, and in fact, it is not new. Lean methodology was there for several years, and that something was highly popular and been used by many OEMs, many industries to improve their production, improve their quality, improve their performance, and all that. But still, there is a gap, right? So what is this is helping now is industry 4.0. So I will talk about the technologies in the next slides, but in this slide, what has been explained it, what are all the benefits which Industry 4.0 is really giving to the manufacturers, right? If you look at it from over here, it's almost 10 to 40. This is something a ballpark number which is arrived from overall automotive segments, right? Around 10 to 40% reduction of maintenance costs. That's something is huge. And 20 to 50% reduction in time to market. That is what I mentioned, how to reduce the time to market so that customer can see the product in time, customer get the parts for repair on time and all that. And then forecasting accuracy has been increased. Cost for quality reduce 10 to 20%. It means the quality is started, I mean, we'll touch upon this, how the quality predictions are happening in the subsequent slides. And cost for the inventory holding is decreased, right? So all these, the reduction of total maintenance machine downtime. So the asset utilization is getting improved. So these are all the value drivers which Industry 4.0 technology is offering. So this is the reason there is a big fuss about the industry is talking about it, and industry wants to implement it in their production line, and also not only in production line, but also in the other value stream areas. So what are those technology drivers driving this Industry 4.0, right? So let's look at it from this wise, anti-clockwise, right? So first is the autonomous robots, right? So robots are not something new to the manufacturing industry. There are welding robo, painting robots, and there are many types of robots available elsewhere in the world, right? But autonomous robots, that's something is becoming very popular. Okay, one example of which we are, used extensively in the industry now is, let's say you want to move parts from heavy parts or the line feeding parts from one location to another location, right? There are autonomous robots. You have to just feed in that this is the requirement for this particular line and this particular station, right? So the robots will come, automatically come, it will pick that trolley, it will go and deliver, and then it will wait there, understand how many what is the production status, and automatically the data gets feed in, it come back to the line feeding location warehouse, and then pick the part and go. So it's becoming very popular now. So it has become completely autonomous. So not only in the supply chain and the material feeding, but also in the manufacturing areas, there are a lot of autonomous robots is there, right? So then the big data and data analysis. This is something has grown exponentially, and it has seen some magical result in the current world. So you would have seen that why data engineers and data scientists are heavily paid. It is all because of there is a great advent of the statistics, right? And also the software in data analytics, in data visualization, right? In machine learning, in artificial intelligence, and all that. There is a lot of development in this. We will touch upon it in some slides. And then the augmented reality, it's about the virtual reality, right? We will see that. Additive manufacturing, it's about 3D printing, right? I believe you have a separate session to go through it in your one of our series of webinars you must have. So it's a very lucrative technology which is in the market now. So there are a lot of benefits in additive manufacturing, right? Then the cloud computing. So everything don't compute at the edge, everything computed in the cloud. So we will touch upon in the slide. Cyber security. So all the data are coming to some single location. So cyber security is a must. There shouldn't be any theft of the data. Then the Internet of Things, IoT, then system integration and simulation. So these are all only the only few technologies which we have I've mentioned it over here. But of course, there are multitude of technologies which are driving this, right? Okay, so I plan to touch upon some of the few technologies and then give you some exposure on where exactly is being utilized in automotive industry or in manufacturing industry per se, right? So otherwise the scope is very big for these technologies, right? So industrial Internet of Things, it is nothing but Internet of Things in industrial world. Okay, so I have one simple example to explain you. So let's take an automotive paint shop, right? If you know about a paint shop has got a lot of critical parameters in it, and it has to be maintained with certain temperature, certain humidity, right, and a certain flow of the paint. All are very, very important, without which the painting will not happen, and painting will have a lot of imperfections if it is so. So all along this paint shop OE, I mean overall equipment efficiency, or the fit or FTT, we call it as first time through, right? So it was always very poor because of a lot of rejections in the paint shop. Running the paint shop itself is a major task. There will be a lot of rejections, right? So to improve it, what is helping us this technologies? Okay, like let's say how the IIoT is helping. So this is a typical paint shop, and we're in a painting room where the paint will be mixed, right? And then there will be different equipments. I mentioned only few equipments, like the thermal is measured by the hygrometer, and then flow is measured by the flow meter, and then the viscosity measured by the viscometer. So all these measuring equipments, if it is connected through a PLC, and the data in real time, it can be collected, and it's going to the main gateway, and from there it goes to the main server, right? So once it reaches the server, so in server somebody call it as MES, manufacturing execution systems, or somebody call it as SCADA, supervisory control system. So so it is a main server in which all the data comes in. So once the data is reaching there, without analyzing the data, or without investing on or investigating about the data is not going to be useful, right? So we need to analyze the data with a proper analytics platform. So this is where the analytics platform come in, right? So using the analytics platform, so analyze the data and understand how the flow is in real time performing, how the viscosity is there in real time, how the temperature is in real time. So you can ask me, it was also there all along before, but what is it now, right? So previously all those data were logged in manually, or at any point in time the data will not be available. But now, since it's been collected in real time, every second, every fraction of second, it's collected as a graph. And I mean, what is beauty about it is, like, if there is any anomaly or anything is detected in the system, it gives back an alarm to the operations that, okay, hey, it's going something wrong, so you stop it, or something you correct it. Or if something, I mean, it's also going to be very predictive in nature. So the trend of the temperature is going very high in the booth, so you have to correct it, right? So all kind of alarm it gives back to the system. So it's going to be almost completely predictive in nature. So it helps in many ways. So this is how the this IIoT devices are helping, and it should be coupled with the analytics platform. Otherwise, this the data collected using the IoT devices alone is not going to be useful. It has to be supported with the analytics to analyze the data, right? Okay. Right. Moving on. I hope I'm clearly audible. I'm continuing.
Yes, sir, it's audible.
Okay. Thank you. Yeah. Okay. So the next is about connected shop floor, right? We touched about one portion of a paint shop is connected using the devices, and the data has been retrieved from the system, equipments, and all that, and how we are utilizing the data for our purpose, right? All that we have seen. But similarly, the entire shop floor, if it is connected, right? So how it's being managed, and how it's going to be helpful, that is what we are going to see now. I have a quick video to explain you on this. You see it, and then I will explain you with the next steps. One sec. So this one is the Bosch plant in Germany, and it's talking about the shop floor connectivity in the shop floor. I'm switching it on.
Our world is constantly changing. The Internet of Things and Services
Oh.
expedites innovations faster than ever before. What seemed like a distant future some years ago is today's reality. We face the fourth industrial revolution due to the means of digital interconnections. At the Bleichach plant, we hold the ideal starting position for the implementation of Industry 4.0. Already today, we operate a standardized production network with 11 plants and more than 5,000 machines worldwide. Due to our standardized machines from our in-house special machine building unit, we're able to draw on over 15 years of experience in the field of interconnected production. Here, processes arise which will change the world of tomorrow. The full automation of our flow of material through technologies such as RFID and MEMS streamlines our logistic processes and reduces stocks. Simultaneously, we create transparency along the entire value stream in real time. Our tools know their optimum lifetime because of methodical analyses and measurements. They are subject to standardized maintenance processes and guarantee 100% traceability. In our constant effort to improve, we access automatically created analyses and evaluations. This way, we can focus on what is important: the availability of our machines. They can detect trends and report critical developments onto the operating personnel before output losses occur. Occurring interferences are being linked to already known error patterns. Recommendations for action are derived from these patterns and enable our personnel on site to act as skilled problem solvers. At the same time, the feedback of the operator creates a closed control loop and a worldwide knowledge database. In the case of previously unknown complications, we immediately contact centrally organized experts via live image. Thereby, we save crucial response time, which benefits the production and can in turn be used for the maintenance of the worldwide knowledge database. The ability of our machines to communicate with each other allows for a flexible reaction to production parameters of upstream processes. The inspection efforts in the final assembly phase are thereby reduced. Flexibility and an awareness of upcoming changes are essential and inevitable. Each individual is being thoroughly prepared for this development and receives the support needed in the form of individual training concepts and a confident and reliable management culture. In all of this, we pursue one clear objective: ensuring the future of our sites and thereby the future of our employees. Because there are some things you simply cannot copy.
Okay, so that's a quick video about connected shop floor. In this slide, I'm talking about the just reiterating the connected shop floor benefits. Okay, what industries are seeing and where exactly they are implementing these technologies and deriving value out of it. So the very popular use case application is the OEE improvement, which I have explained over before. And in the manufacturing terms, it's overall equipment efficiency, and it's a factor of three components. One is the availability, performance, and performance rate and quality rate, right? So this monitoring of this is very important, and it provides the complete health of the overall plant productivity, right? So this is one aspect of it. And then the second aspect is the traceability, right? Okay, so what do you mean by traceability? Traceability is the complete information of a part from the raw material stage to the where it goes into the car, and so the complete information, if it is available, complete information, I mean the process related information, the product related information, if it is available, right, then the traceability will be helpful in many ways. Okay, if I have to explain you one scenario, like let's say you own a car, and in your car due to some issues the vehicle is not cranking, and you are taking it to the dealer, and dealer says, okay, diagnosing it, and then finding it out that the car is having problem with the starter motor. Your starter motor is having issues and it is not cranking, so starter motor has to be replaced, right? So if it's within warranty, you are saved. I mean, you will not be asked for the cost, and if it is outside the warranty period, of course they will charge you, right? So, and I mean, once after that, the dealer will change the part and then give it to you. So as a customer, you are saved. Okay, your purpose is resolved. But for the manufacturer, as a manufacturer, we have to know why this particular starter motor got failed in the system, right? So what I mean typically happens is, if there is no traceability of this part exist, it is very difficult to get to know when was this part produced and what could be the root cause of the problem and what was the issue. It is becoming very, very difficult. So we have to get back the part to the manufacturer, starter motor manufacturer, and understand what is the failure and when this was produced and all that. So I mean to reduce this lead time, if we know the complete information of the process and the product characteristics of each and every part going into the car, right? If we have the barcode traceability available, then it's a matter of minute. We can able to tell that, okay, this part is created a problem in the car. So if we know the root cause, then we can quickly say how many such vulnerable parts, or I mean the defective parts could be there in the other customer cars, right? So in a matter of minute, we can say that, okay, this is the size of the problem. I have another 100 cars. It may be reported in near future. So I have to address those cars. And if there is a clear traceability of the VIN number of the car to the customer, everything is available. I can quickly say that, yes, these many cars available in these location with these customers are going to fail in near future. So that's a kind of a traceability we are expecting. So that is an effort which is happening for almost all critical parts in automotive sector, and it's started happening. And we are also we, in the sense, all automotive OEMs are very particular about it, because it helps us in many ways, especially in the warranty, right? Especially in addressing the field issues, right? Addressing the in plant production issues and all that. So for traceability, it is a major benefit. Okay. So not only that, the for monitoring the live capacity, I mean how many parts produced and what is that the customer demand for to be met, and is the bank built in the sense, is the available parts are okay or not, will it be meeting the next week production or not. So all that, the capacity monitoring in real time, everything, I mean, no need to go and take the stock of situations from the shop floor. Everything will be available in over internet and through to the mobile phone, to the operators, or to the production manager, or to the supply chain manager. So they can able to see from at their palm, at their hand, that okay, this is the current status. So these are all the benefits of the connected shop floor. Okay. And also there are a lot of use cases now we are pursuing for the preventive maintenance, right? So for example, if you know of the welding, right, all the welding tips, for example, has to be I mean, what to say, to be changed after some welding, right? So if it's changed before its life period, it is a waste of money for us. If it is changed after if its life period, then if the weld got failed, it is a problem for us. So the preventive maintenance of those is very, very important. Not only that, in machining, tooling, and all, the preventive maintenance is very important. So if it is managed manually, it will have a lot of problems in maintaining that. So in real time, if we manage it, and automatically there is an alarm system, alert system, if it is available, then it's easy to go and attack it, right? So that's about the preventive maintenance. And also the quality prediction. So let's say One example, if I take any welding or any heat treatment, let's say heat treatment, right? So in heat treatment, usually it is done in a batch wise, right? So usually the inspection or quality assessment of those batches will be cleared based on sampling inspection. We take out of 1,000 parts heat treated, 5 or 10 parts will be taken out, or not 5 or 10, and 2 or 3 will be taken out, and then the part will be destructed for case hardness or core hardness or whatever it is, the specification, the testing will be done, and then the part has to be qualified, right? So what is missing in this is we are depending on the sampling inspection to qualify the production lot. That is one. And second thing, because we have to do a destructive testing, the part has to be destructed and the part is scrapped. So it is a waste of money, right? So now there are a lot of efforts going on by understanding the I mean, input parameters of the process. For example, the heat treatment, there are several process input parameters like the oven temperature, oven, what to say, the pressure, at how many hours it is under the oven, and all those are very critical parameters, right? So the fumes inside, right, the chemical inside. So if we know all the process input parameters, right, which are influencing the product output parameters such as the case hardness or core hardness or whatever it is. So if we can able to derive a relationship using an analytics kind of a machine learning algorithm, or by some analytics, right? So if we can able to build a model, we can predict that yes, this particular batch is running into a problem, this particular batch is okay. So thereby we can save cost of the destructing, thereby we can save the cost, and also there is a high confidence on the parts which are going into the car, right? So we can say around 100% inspection confidence we can have. If the quality prediction, model prediction accuracy is really good, then we can say that yes, the confidence level also very high, right? So if you have any experience in the data science and machine learnings, then you could be able to relate to what I'm saying right now, right? So these are all the connected shop floor benefits. So I have listed only very few, but of course, the OEMs are dwelling upon a lot of use cases and applications in these aspects. Okay. Right. So moving on, the connected vehicles, we touched upon in the earlier slide about the connected vehicles. Right. The connected vehicles is nothing but, I mean, almost this again is growing very fast. Every almost whatever car we are exporting is almost close to 80 to 90% is now connected. In India also, it is growing very fast. Every OEM is giving it with the their car itself, and it is not something to be bought by the customer separately. It's coming with the OEM kit itself, right? So the car will be connected. What is connected vehicles? So the car will be connected with some devices, some IoT devices, like we call it as iPad or iPod. So with those devices connected, this in real time collect the data from the important parts of the car, like ECU, electronic controlling unit, or a steering system, or a brake system, or a airbag system, or whatever it is. The complete health of the car engine and all that data in real time is collected by this devices, and these devices will pass on the data to the several locations, either to the infrastructure, or either to the manufacturer use it for the warranty purposes like us, and or the it will be given to this through the smartphone. So the car, as a car owner, you will be able to see, like by just clicking an app, understand what is your fuel level in the car, what is the brake fluid level, what is the other issues, like everything. I mean, how is your tire pressure level, and is your car locked or not? Even if you are in a remote location, you can able to see, right? So there are multiple benefits which connected vehicles are offering, and this field is highly growing. So it is all using the IoT gadgets, right? So this is something, and really a fascinating field to work with. So similarly, the road infra, the traffic department is heavily utilizing this data, right? So it's not very pervasive in our market, but in other markets in US and Europe, they are using it for the traffic signals, right? It is connecting. The car is talking to the vehicle, the infrastructure, like it is talking to the road signal, traffic signals, roadway signage, and all that, right? So when it talks, like if something, let's say if a car is going to cross a junction, right? If another car coming from the other T joint, right, other location, right? If a car is going to hit, it will give an alarm. Hey, there is something, another vehicle is coming. Please go slow. So it can give an alarm, right? So such a feature is available. And if you go through about some of the Tesla cars, there are a lot of proximity switches and proximity data and all. It is available in advanced driver assistant systems and all that. So it's becoming very popular, right? So that's about the connected vehicles, right? So the next one is cloud computing. So I think we have time. Yeah. So the next one is cloud computing. So the cloud computing is nothing but the data. So as you know, we have started collecting data from many devices, right? In let's say if you have 100 machine in your shop floor, in a minute, whatever data you collect, it will reach 1 terabyte size. So how will we able to handle this data? If a manufacturer has to manage his data and analyze this data, he has to have a own dedicated server and has to purchase that server and keep it there. It's a waste of money, and we don't know and for how many years it will be useful, right? So all OEMs are now looking for a cloud kind of for data storage. So this cloud data, it is not only offering the data storage, but also for the computing. What do you mean by computing? So there are, if you take Amazon AWS or Microsoft Azure or Google Cloud, they're all having a standard customized applications for their cloud. And those applications, for example, if you just ingest your data into this cloud, and the standard packages for OE tracking, the production tracking, productivity tracking, it will give you immediately the results of what is your OE availability, performance rate, and all that, right? Similarly, for the preventive maintenance, a lot of what to say, the applications available in the cloud. So that is what they say, cloud computing. And in addition to that, these cloud supporters are providing a dedicated applications for the manufacturers. For example, if a manufacturer want a dedicated tailor-made solutions for them, then they support it with the in their cloud applications, cloud computing, right? So that is how it works. So cloud computing is again very famous. But still, there is a tug of war between the edge computing and cloud computing, and some manufacturers are very much worried about data privacy, data security, and they are not moving towards cloud. And some manufacturers, they are confidently moving to the cloud. So it's a debatable subject, but it's a very popular and a very growing field in Industry 4.0, right? So the next one is big data and analytics and prediction. I already touched upon this. So it is nothing but, sorry for that. It's nothing but the data. Once the data is coming, how the data is to be analyzed and visualized, and then making it useful for our purpose, right? And either for real-time tracking, to monitor, to understand any anomaly to be detected, or anything going wrong, out of control, or anything out of trend, okay, for that. And also it's excessively being used in for the prediction, right? So the prediction is something is an beauty about the machine learning. It's heavily being used nowadays, right? So not only in automotive, but in most of the fields, right? I've touched upon one example of how the quality is being predicted in the spot welding quality, right? So similarly, there are a lot of applications. So the prediction is becoming very popular now, right? And also the optimizing in the production shop floor productivity optimization, line optimization, and all that stuff. So all that is nothing but once the data is collected, how to make use of the data with the technology available with us, right? So this is what is all big data and analytics. There are multiple tools supporting it, right? The multiple tools available for visualization and multiple tools available for the prediction and multiple tools available for collecting the data, right? So there are several ways in doing it. So there are it's coming as a platform, right? So the solution providers are giving it as a platform, right? So you have to just ingest your data, and then in this platform, if the data is reached, and they do all the sorts of analyzing, visualization, prediction, optimization, all that they do, and then help with the data, right? So there are a lot of players in this field, and it's again growing very fast. Then the blockchain, right? The blockchain, I would say it's still not very popular, but it's growing. If you have experienced previously with any of the finance or any cryptocurrencies subject, you would be knowing about it. So the Bitcoin is something which is the backbone process of Bitcoin is something is by the blockchain. So it's now we are exploring the possibilities of using this technology in supply chain and then also in purchasing. So basically what it does is in the sequencing of processes, the data gets stored in data gets stored as a block, right? It can be any data, so it can be a categorical data, numerical data, but it all will be stored in terms of ledgers. And once that activity, once that step is finished, right, and it will automatically move to the next process, and simultaneously it happens. So the chain of processes, the chain of the data, it then connected together, and once the activity is completed, right, so the data as an encrypted, it will be available, and it is an immutable data, and anybody can see it anytime, anybody can explore it with this data anytime with this. So it's becoming very popular, right? So mainly on the supply chain, we are trying to look for using it. So it is becoming automated way of doing things, like just in manufacturing supply chain perspective. If you see like a part collected from a supplier location or a vendor location coming to the OEM, right? Once the part picked up, the barcode will scan the consignment, right? Once it's scanned, the relevant data, it gets stored in one block, and then the vehicle move to another location, a kind of a warehouse or so, and there again it gets scanned. So that kind of data which stored in that data in the blockchain, and then let's say the vehicle move to the OEM and deliver the part. So once it reaches there, again, once the data is scanned, barcode is scanned, again that data will be stored. So the data gets stored will be in different form, different things, right? And automatically once the quality of that is cleared, that the payment has to go to the supplier, right? So no need to deal directly with this. So it happens everything automated or automatically. So it can aid for automated way of doing things. And there are a lot of trust in this system, but of course there are a lot of challenges in it. So we are looking for doing some pilots, and it's happening right now. Okay, then about moving on, then about additive manufacturing. So this is called 3D printing, and I believe you have some more sessions to add up it. So the 3D printing, to long story short, it's used for the prototype, mainly for the prototype, development of prototype during the development and testing. If you want to know this particular design will work or not, right? And no need to build a separate big tool for it. Just kind of a printing a paper, these parts are getting printed, and it's becoming available. And nowadays there are a lot of these parts can be even printed in the material what we wanted, right? So that something is so not only that, it's also with some very high accuracy level of what we are getting it in the regular conventional manufacturing production lines. Okay, so that's the beauty about it. So of course the cost of 3D printing has not come down, it is still there. And but we are exploring the possibilities, right? So for example, one use case which I have to mention, let's say we are manufacturing some luxury segment car, and luxury segment car usually go for very less volume, right? So in a month, if it is only 3 or 4 cars to be produced, and for those 3 or 4 car parts, we no need to build a big tool for 50 lakhs rupees or 60 lakhs rupees or a crore value, right? So for those 3 parts can be built with 3D printing. It will be, I mean, as long as it should meet the quality requirements. If it meets quality requirements, those 3D printed parts can be even used in the production line. So that kind of an analysis and exploration is going on. So that's again a very growing field. Okay, then the virtual reality, augmented reality. Okay, this one is um, is very popular. So let's say, I don't know how many of you know about Microsoft HoloLens or Google Lens. And in fact, Geo has also launched a Geo Lens. There is a RealWear devices. So these are all the virtual and reality, augmented reality devices, right? So what is that? So what is, first of all, a reality? What you see using your naked eyes is something is called physical reality, right? So on top of it, wearing the gadget, if you can able to impose some digital image into it, that is called the virtual or augmented reality. Okay, on this photo, what you are seeing right now, say there is a machine, right? And this particular person is trying to look at this area, right? So let's say this something is a part which has to be mounted over there, or to be removed or seen over there. Okay, so if we have a over there and then remotely connected with the somebody person sitting in the other end, and he can able to guide if any maintenance to be done on this. Okay, and similarly, if you let's say I will give you a different scenario. You are standing in a production line. There are multiple machines lying over there, and you want to additionally add another machine, right? You have the machine photo available with you, right? But you don't know whether this machine will fit into the location or not. But until and unless a physical machine coming into this place, you'll not be able to know. But using this technology, you can just impose this photo in virtual reality, and then see whether this machine can fit into the location or not, right? So this is one use case I'm seeing, showing, explaining, but there are multiple use cases which we have explored, and it's been seen in manufacturing environment and in quality. On the right side, what you see is the product development, right? So once the product development engineer develop the CAD, he can able to see it in all these angles, and he can able to explain this to everyone, anybody, and it helps in product development also, right? So this is again popular, and in fact, most of the manufacturer use this device as a remote assist device during this corona period and the COVID period. We are unable to move to different locations and different sites, but still the production has to continue. The business has to continue. So how will you monitor what's happening in real time there? So for those, this particular gadgets are used, and it's the cost is also becoming very cheap nowadays. So it's highly being useful nowadays, right? Okay, so we have seen only very few technologies, but if I have to list down, there are more than 27, 30 technologies, right? So, but all those technologies are that matured to scale. When I mean scaling means like to make it in a big implementation to and scale it further. So not all those technologies, because of the cost or because of its use cases and because of its requirement and all and those implications. So if I have to lay down with respect to technology maturity to the business impact, there are very few technologies which can be highly industrialized and be scaled. It's like the technologies like the connected shop floor, right? The what is this 20, the robots and cobots, right? Collaborative robots, and then connected shop floor technology, right? And then the big data analytics, the 11 number, the big data analytics, right? So these are all the technologies is very, very popular. And if we spend time in it, and the most of the manufacturers are utilizing this technology, leveraging this, and then deriving value out of this. But of course there are other technologies in near future once the pilots are over, and if it is the pilots are proving to be highly helpful, then it will move to this industrialization phase, right? Okay, so having said this, I just wanted to list down the challenges, right? So, okay, it's really fascinating to know that all these technologies are really helpful, but it doesn't come out, it doesn't come so easily, and it comes with a lot of cost, right? So the business really has to look at whether it is needed for their business or not. Okay, the small scale business as person, so when business cannot invest on these technology because the return on investment, it will take time, right? So investing in all these gadgets, investing in all these systems, the IoT platform, right? And the data cost, the cloud charges, right? The server charges and all that, it is going to be a lot of cost. It's money, right? So whether they are going to get the investment very soon, that's something is not a very quick process. And big manufacturers are able to survive, but the small manufacturers, they are of course wanted to do it, but they are heavily looking at the return on investment, right? So it's going on a lot of debate and discussion. In some cases it's becoming mandatory, so they have to go for it. In some cases, yes, they will wait and wait for the technology to get matured, and then they are going for it, right? So these are all the challenges we are facing. And then about technology maturity, we touched on this point. And then reliance on the predictions, it sometimes go incorrect. I talked about the spot welding quality prediction. Let's say we leave the machine to predict the quality of the part, right? If the the prediction, if it is going wrong, then the part is going to be faulty, and it is going to create a problem for the manufacturer at the customer end, or at the end customer car end. Okay, right? So if the good quality parts are detected as bad quality, then it is going to be a scrap and it is a waste of money for them, right? So the prediction accuracy has to be improved. If the prediction accuracy is not that great, they cannot implement those machine learning algorithms for their predictions. So the prediction accuracy is also have to be developed. So it requires a lot of data for the machine learning algorithm to learn and build a model. So it's again a lot of cost, and time is also needed. So that's again a big challenge. Very few machine learning predictions are helpful. So we are using it mainly for the preventive maintenance purposes. So for the quality predictions, it's something we have to wait and see, and it's taking some time. The next one is very important. It's company culture and adaptability, right? So company culture. So the long termers, right? The conventional orthodox kind of a company. So they want to do it everything manual. They do not rely on this, right? So changing the people culture. I mean, it's like the how the revolution of IT took place, right? So we could have seen in all banks previously there are no internet or no systems available, but once the systems been put in place, it took a lot of their efforts to change the culture. But yes, it's of course is paid off now, right? So similarly, these technology will take some more time to change the culture in the company, so the adaptability rate will improve then. And then of course, knowledge and resources. This is very important. They have to invest on the knowledge, the people knowledge, and also if there are some companies, they are doing the JV, joint venture with the companies which are knowledgeable and doing good in it, right? So they have to invest on that. Then the data security issues, I touched on this point. If the security, most of the companies are worrying about the security. If they want a good security, if they want to invest on good secured cloud supporter, then they have to pay good money. And so if the security is to be can be compromised, they can go for a less cost supply, cloud supporters. But again, this is an debatable subject, and it's going on. So there are a lot of challenges. I have only listed very few. So it's if you ask me what is the adaptability rate in automotive sector, there was a big fuss about it 2 years before, right? Everybody was talking about it, but the trend is a bit slow down because of all, there are multiple reasons for it. One is the investment. Everybody is worried about at this point in time due to the COVID situation, the economic slowdown. So the running their business itself is challenging now. So whether to invest on these technologies and then waiting for the payoff period, so that's something is very challenging. But still, there are some manufacturers, they don't want to wait and they are going for it, right? So it will take some time, right? So that's the scenario in the automotive sector. And so what is my advice to the engineering grads who are going to pass out, right? The advice is develop your skills on the new technologies, right? There are a lot of new technology we talked about. So you can have an overall understanding about all the technologies, and pick some technologies for whatever you understand is something is very important or passionate about. So you can look at those technologies, and a lot of material available in internet, right? So nowadays the education is completely democratized. So you have online courses available. So online material is available, right? So you can go through that. So that's about it. Then the hands-on training, wherever possible. If you get an in-plant training or wherever possible, or you go for that, right? So even in IoT, no need to wait for the what to say, the industrial experience. You can even do an IoT in your home environment and look at how the IoT is supporting your home needs, and thereby you can understand how it's going to support the industrial needs as well, right? And you have to be patient because the technology is growing. It is going to take some time, and continue to keep abreast of the developments. So once you know that some technology is helpful, you cannot stop with that. For example, the data science, right? It's growing very fast, and all along the machine learning was ruling it, but now it's deep learning. And deep learning, again, a lot of programs and a lot of libraries available, a lot of things available in deep learning. And moving on, the what to say, the different types of improvement have is taken place in this data science, right? And of course, they're not last but not the least, not to forget the core skills, right? The core skills will remain as core skills. What I mean by that is the core automotive, how the IC engines, right, internal combustion engine work, how the battery engine works, right? How the automotive is performing, how machine works, and how all the electronics of the machines performing, right? So that's something is core. It is not going to leave forever. So in addition to core skills, you have to learn these industry 4.0 technologies. So that will be helpful, right? So that's the quick advice which I thought will be helping you who are going to pass out from engineering. So with this, I think I can pass over here, and I can take questions if you have any. And if you want any clarifications, I can touch on those, right? It's over to you. Thank you. Yeah. Am I audible to you clearly? I think if you're talking, you have to unmute yourself. Okay. Yeah. I think pretty much I could able to cover. Over to you, Professor. So if you have any questions, you can continue and I will clarify that. And
So the
let's see.
chat box, you have a question. Can you please look at this?
Yeah, 1 second. There is a chat box. Why it's not visible to me?
Can you see the questions, sir?
Yeah, 1 second. No, I'm just sharing my screen on the
You
chat
can stop
box.
sharing, sir. You can stop sharing.
Okay. Right. Yeah.
You can take the chat box and you can see.
Okay. Okay. Maybe the questions are not posted to me, I believe. Do you see any questions?
Yes, sir. Sir,
Yeah.
you told discuss about quality prediction.
Right. Yeah. So you want to know about you want to explain that example which I mentioned?
That's what
Okay.
one question from the participants.
Okay, fine. See, maybe I will repeat the quality prediction which I explained, right? So let's say in an spot welding, right? So in any welding, I think I explained about heat treatment. Maybe I will touch upon the welding. So in spot welding process, once the welding is completed, in order to assess the quality of the part, we have to cut open the part, distract the part, and then check what is the weld nugget diameter or whatever it is, the weld depth and all that, right? So we have to distract the part. That's the only way, right? So what's happening in this scenario is, because we are distracting it, we have to we have to scrap the parts. It's a waste of money, and only the sampling inspection can be carried out. So because sampling inspection, there is no 100% confidence that other parts are okay. There is no confidence on the other production parts, right? So such things are prevailing. So what we were trying to do was, using the key process input variables of this spot welding, like in the spot welding, what are all the key process input variables, like the resistance, material thickness, the and electrode material specifications, the electrode gap, right, and all those, the weld time, current, voltage. So these are all the key process input variables. So using these input variables, there is a correlation we can able to create and build a model to predict the weld nugget diameter. So if the correlation is rightly achieved, and if you can able to predict the weld nugget diameter, right, so we can clearly say that every weld we produce is good or bad. So in real time, if you can able to connect it to the machine, as we weld every spot, right, we can get to know, in the sense the operator can get to know that the weld quality is good or bad. Okay, so this is something will be very helpful. The operator no need to wait for the destructive testing need to be carried out, no need to wait for the batch to be qualified, and inventory can be reduced, and also there is 100% quality control can be established, right? So these are all, this is one example I am giving in terms of the quality prediction using the IIoT and using the machine learning technology, right? So similarly, there are a lot of examples which can be available in these areas, right? So if and I mean, anomaly detection is something is very popular, right? So if something in the process is going wrong, right? A typical process parameter which is highly influencing the product characteristics, that something is going wrong, we can quickly predict that yes, this is an anomaly, stop it, stop the production, or change the production, or alter it. So that kind of prediction we can do it using these IoT technology and machine learning. I hope it is you can understand a bit more about it. Thank you.
So any other questions from the participants? Also, you can unmute and you can ask any questions or queries. Any other queries from the participants? Okay, sir. If no other questions, can we wind up, sir?
Yeah, sure. So,
okay, so thank you very much from the Department of Mechanical Engineering, the College of Engineering, sir. So let me invite Vinod, sir, for the vote of thanks.
Sure.
Okay, sir. We have come to the end of this session, and let me propose the vote of thanks. And this session was really fruitful and also informative, and we could know more about the IIoT and connected floor, connected vehicle, etc. Thank you very much. And on behalf of the entire staff of mechanical department, I extend a warm, hearty gratitude to you, sir.
Sure. Yeah. Thanks. So,
and okay, I also thank to our HOD, Dr. K. Shanmugesh, and all the coordinators and also all the participants. I thank all of them. Thank you very much. Thank you.
Thank you, sir.
Yeah, thank you. It's my pleasure to participate. So thanks for the opportunity. I could get a good sense of the sharing, and it's really a great opportunity for me. Thank you.
Thank you.